Hello everyone and welcome to yet another PTC Nordic Talks webinar, where we are honored today by having Mahesh and Sham and Tuhin from Birlasoft for a session on smart connected asset and factory. But first, a very quick introduction about myself. My name is Torbjörn Peterson and I'm the Alliance Manager for PTC in the Nordics, and we are running these webinars at the same time every week. But we are also inviting customers and partners to give some inspiration on digital transformation to see what is possible and how to make things happen. And all the past webinars have also been recorded and are to be found on the registration site. The agenda for today is first a quick overview of PTC by my colleague Carl from the customer success team, and then our guest from Birlasoft will start by introducing themselves and touch base on a few challenges, how to address these, and then explain some of the business outcomes. And at the end, we will have a Q&A session, so please keep your questions to the end. So now over to you, Carl.
Thank you, Torbjörn. So PTC is an international software company with headquarters based in Boston. So we are developing software mainly for manufacturing companies since 1985. We offer tools for the digital transformation, such as CAD for design, PLM for managing data, IoT for connecting products or manufacturing operations, and augmented reality to visualize and interact with the digital thread. To you, Sham.
Okay. So, yeah. We have a team from Birlasoft, and Tuhin, just can you introduce yourself quickly, and then I will have a round of discussion with myself and then Mahesh. Tuhin? Looks like. Hello.
You're on mute, Tuhin.
Okay, that's fine. So Tuhin is our Director of Business Development, and he's predominantly based off of in Europe, and responsible for driving the sales for the digital manufacturing and entire digital HVU. Myself, Shamdutt, you can call me Sham, and I'm Global Practice Director, heading the digital manufacturing practice, and I'm based out of Pune. Mahesh, if you can quickly introduce yourself, please.
Sure, Sham. So I am working together with Sham and leading the practice for the IoT services and solutions. I have been involved with a lot of innovative solutions development along with our partners like PTC, and that's it. Been there with Birlasoft for a long time now.
Okay. So Tuhin, if you are there, now we can quickly introduce Birlasoft. Okay, fine.
Sure. Can you hear me well now?
Yeah. Go ahead, Tuhin.
Okay. So very briefly, I know that many of you may not know Birlasoft or know much about Birlasoft, but we are part of a Birla Group. Birla Group is quite a prominent group in India. Everyone heard about Tatas, right? So there is a funny analogy that Tatas had no sons and Birlas had many sons. So, they created many groups of companies. So Birlasoft is part of that group, and we have been operating in more than 30 years into the industry. We focus on majorly 5 verticals: manufacturing, energy, life sciences, banking, and communication media. And of course, our services cut across horizontal like ERP, digital transformation, infrastructure, and cloud, right? The experience that we bring in is a strong convergence between the OT and IT, and that's where experts like Mahesh and Sham brings that real experience on back of the digital transformation experience. So yeah, please feel to ask your questions or reach out to us. Sham, yeah.
Okay.
So this is just briefly where we are located. So yeah.
Yeah. Okay. Okay. Well then. So I will just spend next 15 minutes quickly running through introducing on the what is smart manufacturing, what is the customer saying to us, what is our point of view, and how do we build this roadmap and offer the solutions, and then what are our solutions accelerators, and the use cases or the project which we have done with our customers around these themes. Okay, so just a preface here, like as you have seen that we have a lot of manufacturers across the globes are working in one form or others on whether it's an industry 4.0 or the manufacturing, smart manufacturing, or the factory of future or factory of tomorrow, and all are driving, doing their changes at a fundamental level, right at the systems level or the process level, in order to drive the productivity, efficiencies, reliability across the different assets, and then finally the sustainability to optimize and maximize it. Okay, that said, for the today's topic, we are going to focus on the key, I would say, the levers or the foundations which we help most of our customers driving these goals using this four pillars of solutions, so to say. Okay, and as you see on the screen, it's shop floor real-time visibility, connected operations, asset performance management, and then the manufacturing digital canvas. So these are the four blocks which we'll be double clicking and then discussing more on it. Okay, so what we hear from the market, okay, when we start discussing or when customer comes to us with their problem statements, we have tried to summarize or capture it into just 4 bullets here, but there are many. But just to give you the key points, is how do I do the IT, ET, OT, different domain integration so that I start seeing the visibility, okay, in my systems level, in my machines level, in my process level, okay, to address the the goals what we have said, that maximizing the productivity or efficiency or the reliability or sustainability. How can I get the visibility? Because today most of these uh, plants are really manual, paperless, and not very automated one. So how can I get the? That's the first thing, and the talking point where they come to us and say, okay, do you guys help us setting that up? Okay. The second is like, okay, well, we have that, we have the systems in place, uh, but then how can I move to the next level of maturity where I can start doing the co-innovation, start collaborating with you guys in terms of experimenting and doing uh, the platform where we can build those use cases on a very continuous basis, and see what is the right use case where I can get the maximum benefit, where I can get the faster return on investment. Okay, so that's where again the customer comes and say, okay, can we have this platform? Can I have the platform for doing the analytics, the machine learning part of it, so that I can start optimizing across those domains. The another question that comes is like, okay, I have a bunch of old legacy applications, and some are like under the they cannot be supported or sustained. Some are cannot be connected to the connected to the new systems, or there are a lot of duplications around the applications because over a period of time we have accumulated so many applications. Now there are redundancies in those applications. So how can I rationalize those applications? How can I migrate those applications? How can I start building the start my journey moving toward the smart manufacturing or the industry 4.0 journey? Okay, so that's it. Like another set of people who comes to us is saying, okay, how can I bring in the agility or the flexibility along my product lifecycle management so that I can start seeing where are my parts. If I'm getting the parts from the supplier, how can I see upfront what is the quality that I'm going to receive, where I'm going to assemble it? Can I check on those quality, uh, prevent those quality beforehand, or give them recommendations or suggestions so that whenever the part switches my plan, it's absolutely in line with the specifications. Okay, so these are the few things which customer keep asking. In general, if I want to summarize this, is like they are looking for the real-time visibility into their existing shop floors, into systems, the processes, the transparency between the different operations, and finally the flexibility into their process and systems so that they can align, adapt to the changing conditions, whether it's a change in the rush orders, changing into the specification of the product, or your machines going down, and what would be the right alternative to these machines. So these are the things which they are looking for to drive the productivity, efficiency, sustainability, and reliability in an holistic way, not in the silos, but into an integrated way so that they can start optimizing and start driving to the world-class manufacturing. Okay, so just moving to the next slide quickly. So what is this world-class manufacturing? What is the customers when we talk to they are looking for? So these are something which we have highlighted here. One, if you see on the point number 1, it's more on the process efficiency, the process stabilizations, reducing the process deviations, hence improving your quality, yield, and the efficiency uh, of the processes. Okay. Also, the how can we identify the bottlenecks quickly so that the production flows are optimized using just in time or just in sequence, right? Which is overall giving us the yield improvement dimensions, or the one lever that customer is looking into the efficiency improvement. The other dimension that they look at us is this health, safety, and environment, where they want to see that whether my operator at the shop floor or the supervisor at the shop floor are executing the right instructions to the context, to the situation that they are in, and they're not doing something which is not been complying to the SOPs. Okay, so this is where the my quality will be ensured. This is where the right alarms and alerts will be given to my operators or supervisors, uh, giving them the safety. And the third part is the environment, where they're looking for how can I optimize the use of my resources, whether it is the energy, water, gas, or for that matter, the lubrications that goes into your machining thing. How can I optimize so that the consumptions, energy consumption of those starts improving, and the CO2, which is the norm, which is now all the enterprise are driving, and they have taken a very, very challenging goal of reducing the footprint by 50% in next 3 years. So how can we have those systems to improve those carbon footprints? The third lever is the asset lever, whether it's the assets are your production assets, whether they are the operations assets, or whether they are logistics assets, any kind of asset. How can I make sure that my assets are working reliably and they have minimal downtime, right? And have the higher productivity, higher utilization. So that's again one of the fundamental goal which the most of the enterprises and the companies are looking in order to improve on that. So again, the some of the which I have put the improvement areas as again based on the average of what our customers are looking for. Like they want to have the asset downtime improvements, they want to have the asset utilization improvement by 3 to 5%. uh, and the last lever is like, okay, now we have all this, how can I overall improve the the throughput of my entire factory, so that I can play well with the dynamic demands that coming in. I can be well on the time delivery, right? And with the optimized cost. Okay, so these are the 4 levers around which the any plant or any factory or any enterprise looks at when they start building the roadmap for Industry 4.0. Okay, so how we help them achieving these goals is at a very fundamental level. We do the consultative based uh, uh, engagement, wherein we map their existing processes, whether it has the what is the volume of products they manufacture, or in a shift or in a day, what is the product variants they have, what is the complexity within the processes, and basis that we map these solutions or the problem statement, whether it's on the co-production, quality, inventory, or maintenance, into around 40-45 use cases around that, and then see basis their key priorities on the business goal, whether productivity is my the first priority, or whether the health safety environment is my first priority, or whether uh, getting better quality and yield is my must priority. So keeping on that, what would be the good starting point? What is the low hanging fruit? What is the best building block that we can go on? So basis that, we then go to the step 2, where we start building the real-time visibility and to the shop floor, and start the journey in the process of getting the unified data models. Okay, so that this data model can be then projected or leveraged into the different, I would say, functions like analytics or machine learnings as we go into this journey. The third thing which we focus is, now that we have the real-time visibility into the systems and the processes, how can we now start integrating different operations like production, quality, inventory, and maintenance in a holistic way, so that whatever the intelligence we have extracted from the real-time visibility can drive this process in a very holistic way, in a collaborative way, so that the whole systems become more resilient, it becomes more agile. So even if there are some disruptions or deviation, systems can come up very fast in a very systematic way in a shorter time. The fourth lever, or the milestone what we look at is, then once we have that, how can we digitize completely the entire assets across your shop floor, your plant, or the enterprise, again in a very holistic way, and see that how the asset performance, its health conditions can be monitored, and its performance can be optimized. Not only that, but then we integrate the asset performance along with your operations performance, so that now it becomes a one holistic story, wherein it comes to know, like, if certain assets are going to go down in X time period, what is the action that I need to take in changing the schedule or plan, or the plans, or the control plans which is there in the shop floor. Okay, and then automating those with your field service automations, and then having a very model based sustainable model. So this can be sustainability around your resource consumptions, it can be energy, or it can be the cost, whether it's an operating cost or the manufacturing cost or the quality cost, which can be optimized at the different value chain. Okay, so it's not only the efficient plan or the efficient utilization, but at the same time, it has to be cost effective, right? So we at the Birlasoft, have clear chalked out 4 themes. Okay, one is the shop floor real-time visibility and automation. Here, the focus is digitizing your all the 4 M's, that is man, machine, material, and the methods, into the shop floor, to digitize your manufacturing and machining processes, stabilizing those processes, uh, making them more responsive to any deviation and disruption as it happens, so that the different roles like operators or supervisors or planners can get the early notifications of such deviation, and they can act right in time before any major issues or fault condition happens. So that keeps your plant under check, and hence it makes your plant more reliable, more consistent. Your processes are well within the specifications all the time. Okay, and in this case we talk about, let's say, if you are aware of something called as the OEE of one particular plant, okay, or of a particular machine or a line. Okay, the next what we focus more is on the connected operations. Here again, it's more of connecting your production controls along with your in-process quality, your predictive maintenance, and then the executing the e-Kanbans, which is more of your pull mechanisms, auto replacement, right at your line site, at your supermarket side, so that as and when the resources, the inventory levels are going down, it triggers and alerts asking for pushing the material right in time, so that there are no bottlenecks or the starvation that happens because of lack of material. Okay, and once we have these two covering the production quality and inventory, then it is more on the asset focus, which is it can be your static assets, non-movable assets, or it can be a moving assets like the AGVs or the conveyors, which is moving from one place to other, or it can be any asset within the four walls of your manufacturing or into the field operations. We work around in order to doing the asset remote monitoring, tracking, and connect those with the inbound and outbound track and trace application. And then once we have all these three foundation layers, then we have those aggregated, integrated into what we call as a manufacturing digital canvas, which takes the whole journey to the next level, where we start doing the predictive analytics, the prescriptive analytics, building the digital twins so that your plant become more autonomous, adaptive, and with very minimal human intervention. So wherever there are any deviations in your performance, it will automatically trigger the right corrective action to the right role at the right time. Okay. So this is what our manufacturing digital canvas looks like, and we have actually deployed and rolled out to many plants in US as of now. The first level of the layer is, as you see, is a standardization, and the standardization is all at all levels of your ISA 95 levels, whether it's your uh, shop floor control systems, PLCs, or the SCADAs or MES, or whether it's your asset templates, enterprise or plant level, energy management systems, or whether it's your ERP systems or ERP-like systems for order and monitoring system. So once we have connected these different sources of data, which are actually oscillating at a different frequency and at a different volume of the data, we aggregate those data into our platform, what we call as the manufacturing digital canvas, and it can be a PTC platform where we integrate those into an unified data model. Now, once we have this integrated data model, we start streaming out into the different branches like visualizations, helping providing the 360 degrees view of your shop floor, whether it's a production KPIs or whether it's a plant asset KPIs or whether it's a energy KPIs, or it can be your cross-functional KPIs. So this and been designed in such a way that it is depending on the role based, they get to see only those KPIs which they are supposed to look at, not all the view of that. Okay, and this cuts across right from your lowest level of the hierarchy at operator level to the I would say to the CXO levels. Okay, right from your operators, supervisors, managers, and the executive levels. So they will have the different views of their the KPI and dashboards, and they have all are having the informed actions around each of these KPI to act upon. And once we have that, then we move to the analysis part of it, where we can provide a quick diagnostics around where the fault or issues are happening, or the predictive analytics, and giving them the actionable dashboards and reports for the closed loop systems. Okay. Again, I said on the asset performance management, we do end to end, right from asset uh, connectivity, digitizing the asset features, and then monitoring the assets, tracking the assets across the entire life cycle, and then driving the intelligence right across the field service management for any of the, if there are any fixes that needs to be done, what are those right fixes, what spare part is required. And this all is possible with the help of building the predictive insights and digital twins. Okay. Some of the accelerators what we have, uh, which can be quickly deployed, built, is the prod logics. Prod logics is something which sits over the your shop floors, connecting different lines, machines, and it provides a digital twin, uh, meaning that it will monitor the KPIs, let's say OE in this case, and it identifies which of these levers of this OE is contributing more, whether it's a performance loss or whether it's a operations loss, or whether it's the downtime losses, or whether it's the quality losses. Which of these losses are contributing? What would be the right action? What is the root cause of this action? And then generating and work instructions appropriately based on the context for the actions in a collaborate manner. Okay. IntelliAsset is again the accelerator what we have for connecting both moving and non-moving assets, and then driving out the intelligence in terms of its performance, its health conditions, and then driving it into your enterprise asset management or the operation management for the maintenance and the work order tracking and tracing and the closure. Okay. Uh, Again, the asset monitoring here again is more of the same part of the IntelliAssets, but this is specifically to do in terms of monitoring and tracking the assets rather than providing the analytics part of it. It is the fundamental block which sits into your IntelliAssets, and it helps you to give you the descriptive analytics like why the asset is not performing, why it is the downtime of this particular asset is high, where exactly this asset is, and all those basically providing the context. Machine logics is again connecting the machines at your shop floors, and it gives you the insights around how is your machine performing to the particular parts that is manufacturing, why the performance of this particular machine is not in line with the same type of machine manufacturing the same part of line part, where are those issues, and then fixing those issues and the bottlenecks. So these are the quick accelerators what we have built in order to address the solutions around the roadmap what I just showed. Here are some quick touch upon the use cases or the I would say the projects that we have delivered. So one of those is for the Fortune 500 auto manufacturer, where we have connected. There were 7 plants for building the manufacturing detail canvas, building the unified data model, which I just showed you in terms of understanding and providing the view for the KPIs across different domains like plant KPIs, asset KPIs, energy consumption KPIs at a very different role, and so that the real-time visibility and the transparency between different operations are available. So this has been rolled out across the about 7 plants as of now, and there is plan for rolling it out about 20 plus in the coming months. The other use project what we have done is for one of again for the automotive manufacturer here in India who is manufacturing two-wheelers, and one of his problem was the compliance issues or the quality rejection issues that's coming in from the different suppliers. Okay, and at the end of the day, that was a lot of rejections that's happening, a lot of rework that's happening, and it was pulling down its yield and finally the productivity. So the solutions what we have provided using the PTC ThinkWorks platform is a distributed quality control, where we have covered about 80 processes of this particular product across 50 plus suppliers. Okay, as of now, and the now the improvement that customer sees is that he comes to know at a very early stage if certain parts or the uh, assembly components are going to get deviated. He gets the alerts, and whether those can be repaired or machined further, or whether it has to be scrapped, it happens at the supplier side, not when the parts comes to the actual the manufacturer plant. Okay. The last one which I want to quickly touch upon is the predictive maintenance, which we have deployed again using the PTC, where it's again for the spinning mill, okay, for textile industries. These are fast operating operating where there is a high frequency of frictions between different components, whether it's a gearbox, whether it's your flanges, whether it's your bearings. That has a a lot of wear outs wearing that happens, and now what has happened is with this solution, the customer what we are working with, he has actually taken these solutions and install it into his distributor, so that the machines that he is providing them to manufacture those textile materials, he gets an early warning whether this part is going to go down or whether the spare of this is required right in time, so that there is the downtime can be addressed. Okay. So these are some three among we have chosen among 50 plus such use cases for this session. So with this, I think I am pretty covered. Though I have crossed 1 minute on that, but that's fine. So we can have a question answer sessions open, or Mahesh, if there are any questions that has come on the chat, we can answer few of those in next 5 minutes.
Thanks a lot, Sham, Mahesh, and Tuhin for sharing a lot of amazing inspiration here in this session. So as you said, let's open up for some questions. And even if a little bit over time, we could also, utilize the fact that we could send some questions on the chat as well. So please go ahead. If you have any questions, raise your hand.
And Birlasoft team, this is Hemant here. I work for L&T Technology Services. Just one question, and it's very basic one as well. How do you define the manufacturing digital twin for your customers?
Okay, so Hemant, it is not a day one journey. So as I talked about the manufacturing digital canvas, okay. So for us, first we have to have the data that's coming in from the different sources into a unified data model. Okay, so once we have that unified data model, so we define for our customers into three predominant blocks. One is your physical model, the second one is the information model, and the third one is your virtual model. The virtual model, what we create. So once we have this unified data model, which predominantly maps your physical model, which flows into your regular information model, where you have the knowledge graphs, you have your AI/ML predictive models, and which gets linked to your virtual models, which models the physics of that particular machines. Whether I just talked about the friction, right? So basis on your spindle speed or your depth of cut, we create the what would be the coefficient of the friction. So that is a physics model. Then there is a behavior model, like basis if the friction, if that particular RPM, okay, or your spindle speed is causing the higher coefficient of the friction, then what would be my cutting force torque? Okay, then for that cutting force torque, how is the right depth of cut or the right spindle speed to be applied? Okay, so with these three components, we are able to monitor the regular stuff of your processes, the machine performance. Once we get those things, then we do the analytics to get into the insights and the root cause of it. Once we have the root cause, then for that root cause, we do the predictive or the knowledge-based understanding using the historian for this particular case. When it happened in past, what would be the right action which we have taken, which has yielded the lower cost and the shortest time to fix it, and that is fed back into your machine. So this is how we defined Hemant, just to give a very short answer to the larger topic.
Thanks, Sham. Thanks.
Thank you. Time is unfortunately running out, so many thanks everyone for joining, and of course a special thanks to you, Sham, Mahesh, and Tuhin. But also, please utilize the fact that you will stay a little bit longer, for any questions on the chat. So with that, I wish you all a fantastic weekend and see you next week.